In this problem, we are asked to find the first four partial sums of this series, use that to guess at a formula for Sn, and then use that to guess at an actual value for the series. So to begin, let's start by finding A1 through A4. A1 is 1 over 11 to the first, A2 is 1 over 11 squared, A3 is 1 over 11 cubed, and A4 is 1 over 11 to the fourth. So those are the first four terms of the series. S1 is A1, which is 1 over 11. S2 is A1 plus A2, so that's these two things added together. 1 over 11 plus 1 over 11 squared, and I'm going to organize these in a funny looking way so that we can find a pattern in the future. If I multiply this by 11 over 11, I get 11 over 11 squared plus 1 over 11 squared, which is 11 plus 1 over 11 squared. I'm going to leave it like that. S3, A1 plus A2 plus A3. Well, A1 plus A2, we've already figured out that's right there. That's 11 plus 1 over 11 squared. And then A3 is 1 over 11 cubed. So if I need a common denominator, that would be 11 cubed. So I need to multiply this by 11 over 11. And I get 11 times 11 plus 1 over 11 cubed plus 1 over 11 cubed. Well, that's 11 squared plus 11 plus 1. 11 squared by distributing it in, 11 by distributing in, and then adding the one that's over on the right, all over 11 cubed. That should have been an S3. My apologies. S4 will be A1 plus A2 plus A3 plus A4, which is the value that we just calculated, 11 squared plus 11 plus 1 over 11 cubed, all over plus 1 over 11 to the fourth. If we do the same thing, I'm not going to work out all the details, but if I multiply by 11 over 11 again to get a common denominator, distribute the 11 through, add everything up, I get 11 cubed plus 11 squared plus 11 plus 1, all over 11 to the fourth. So we've got S1, S2, S3, and S4 in a way that's easy to see the pattern. If you would write these all out and figure out what those numbers are, the pattern would not be obvious at all. But as it's written like this, they're fine. They are the answers to the question, but it makes it easy to guess at a formula for part B. Okay, so for part B, what do we have? Well, we're going to, the denominators will just be 11 to the n. The numerators will essentially be 1 plus 11 squared plus 11 to the n minus 1. So Sn, in terms of a formula, we're going to have 11 to the n here. We're going to have 11 to the n minus 1 plus all the way down to 11 squared plus 11 plus 1. Right, so notice that the final exponent in the numerator is 1 less than the denominator, which is exactly what I wrote right there. 11 squared all the way down to 1. Denominator is 11 to the n. So this is the answer to part B, right there. For part C, guess at the limit as n goes to infinity. As it's written, it's not obvious at all what to do, and so we need to do some algebra tricks in order to make that work out a little bit better for us. Many of these are given in the text version of the example here, so I'm not going to go through all of the gory details, but I will give you some of the basic ideas of what's happening in this algebra. We can think about this. This 11 to the n minus 1 all the way down to 1. I'm going to think about that as x to the n minus 1 plus x to the n minus 2 plus x cubed plus x squared plus x plus 1. I'm going to think about this as a polynomial. Think about this as a polynomial where x is equal to 11. Right, so if I plug 11 into this, then I'm going to get Sn right here. Okay, so this is just simplifies our algebra a little bit so we don't have 11s all over the place, and it really doesn't matter what the fact that this is 11. This is going to work for any value, not just 11. Okay, now here's the trick. Here's the key point. If I take the polynomial x to the n minus 1 and I divide by x minus 1, so this is a long division, a synthetic division type situation. My claim is that that's exactly what you would get. This whole piece is that numerator right there. Just to give you just a couple of quick justifications. If I took x squared minus 1 and I divided by x minus 1, well, x squared minus 1 is x minus 1, x plus 1, divided by x minus 1, and the x minus 1's canceled, and I get x plus 1 back, which is exactly what this is saying. If I start with 2, if I have x squared minus 1, then I better get just the x minus 1, the x to the 1 to start, right? 1 less than the denominator, all the way down to 1. And this actually happens no matter what. If I take x cubed minus 1 divided by x minus 1. Well, x cubed minus 1, as it turns out, you might have learned some formula at some point in an algebra class, but as it turns out, this is x minus 1 times x squared plus x plus 1. That's how a cubic, this is a difference of cubes and how it factors. The x minus 1's will cancel, leaving me with x squared plus x plus 1. And so my claim is that this is always true, no matter what, whether this is a 2 or a 3. If I take x to the n minus 1, divide by x minus 1, then I'm left with something that looks just like this, up to 1 minus wherever the starting exponent was. And so we're just going to take that as true, which means that this formula becomes x to the n minus 1 all over x minus 1 all over x to the n. Right, so that numerator is this piece right here. The denominator hasn't changed. So that's x to the n minus 1 over x minus 1 times 1 over x to the n. And now's where we'll go back and remember that x was 11. And we just use that to simplify the notation a little bit. So if x is 11, this makes 11 to the n minus 1 over 11 minus 1 times 1 over 11 to the n, which is 11 to the n minus 1 over 10 times 11 to the n. Right, all that I did was turn that 11 minus 1 into 10 and then combine my two fractions together. And this is a formula for Sn. Now finally, part C, guess at the limit. So let me put that formula up here. We found that Sn was 11 to the n minus 1 over 10 times 11 to the n. What is the limit as n goes to infinity? Or so what is the value of this series? Well, remember that we only need the terms, the biggest degree terms. If I only need the biggest degree terms, that means that this minus 1 I don't care about. As before, I'm only looking at the things which contribute the most, which in the numerator is the 11 to the n, and the denominator is 10 times 11 to the n. So that's 11 to the n over 10 times 11 to the n. The 11 to the n's will cancel, and I end up getting 1/10 as the final sum.